Alright, so what are absolute value functions? So you may have heard the term absolute value or modulus, and so basically these words represent the distance of a real number x. So we could look at this on a timeline, and so it's probably worth stating that this is represented, so absolute value functions are represented as that, so that you'd call that mod x. So if we were to draw a number line between 0 and x, this distance along here is represented by this mod x here. And this works both in the positive and negative scenarios. So basically how it works is that, have a look at some basic examples. Let's just say, so I'll just draw not a number line, I want to x equals 3. We'll say x also, x equals -3. And then what we'll do is we can put this, and this is just random examples, we can write this, so mod 3. We evaluate this by saying that that equals square root 3 squared, which equals square root 9, which equals 3. So it takes us back to the original number. But then you'll notice this actually does the same for negatives, but not with negatives. So you got mod -3 would equal square root, and we'll use brackets this time, -3 squared, which equals root 9, because -3 multiplied by -3 equals a positive, so +9, which goes back to 3 as well. And the reason this is because distance that we have here cannot be negative exactly. So using this modulus and this method is a really great way to show distance, making sure that it's positive. And this is just a general formula for this, is you'd show it as that equals square root x squared. Pretty simple process to follow. However, there's two other things you might want to consider. Is that let's just say we had got another number line again, but let's just say this one's a bit longer, and we've got, I don't know, some random points along it, and then this one to jump up all the way to 8. And then what we can do is we've got two separate distances here. And so this one's going to be 3, and that one's going to be a massive 9. And so what will happen is we can't anymore represent this as a simple function, but what we do is we convert it into an algebra definition. So the general formula for this is mod x, where you've got multiple points, equals, and this is just a general formula example. So x, if x is more than and equal to 0, and negative x if x is less than 0. And this is usually where instead of, and this is my bad, instead of having this -1 here, it's to be a 0. And so you have the negative and then the positive side. And you would split this up. So maybe in that scenario I showed above, instead of doing the 0 here, you would have, say, -1 or something. But you get the idea there. Now these functions have applications in all sorts of different areas, and as a result they can actually be presented in a lot of different formats. So you can have, obviously using a bunch of different letters, just plain modulus. You could multiply them. So if you're multiplying A and B, and you can represent this by putting them side by side. You can minus them or add them. You can square these absolute functions. You can even divide them in some cases if you really wanted. There is a very wide range of different formats that these functions can come in. Alright, so now we're just going to have a look at these few examples and see how we'd actually evaluate them. So the first one, It's pretty straightforward. I'm going to do the full method, -2 squared, which then equals square root 4 equals 2. And then the next one, what we're going to do is you're going to do these separately. So we got 2 times by mod 3. And so then that will equal, we know that -2 will just become 2, and mod 3 will just become 3, and then so obviously 2 times 3 equals 6. Now we've got another multiplication, but it's actually within it. So this time we've got -2, I'll put these in brackets, and 3. So then before we actually evaluate the modulus, we're actually going to evaluate the brackets inside it. So we have -6, and then that will just result in normal 6, just like what happened before. So even though these have a different format, they still result in the same number. And now on to the next one, we've got a minus b, so then we can show that as mod -2 minus 3, which equals modulus -5, which obviously equals 5. And then for this one, we got them separately, so -2 minus modulus 3, which equals 2 minus 3, which equals -1. So unlike the multiplications, minusing these actually results in different numbers when they're separated or in the same. And then squaring them here, it's pretty easy. It's got -2 squared, and then that will obviously mod -2 will evaluate to 2, and we keep the squared there, so that's squared, which just equals 4. And then for some divisions, so what we do here is we'd say that equals mod c, which is -4 over -2, and then we'll evaluate the modulus again, which -4 over -2 just equals 2, so we'll just say that's mod 2, and we know that just equals 2, like that. And then a little bit similar with this one, mod -4 over mod -2, which will equal, we know that modulus -4 will just equal 4, and then 2 is 2, which just equals 2 again. So again, dividing these are very similar. Alright, so let's do 2 more that are a little bit different in terms of how they're structured. So we've got x equals -3, and then we got these absolute functions here. And so what we're going to do is we'll evaluate them by inputting the x values. So that'll be obviously 2, -3, plus 1 over 1 minus -3, which we know would end up being -6 plus 1 is 5, and then 1 minus -3, so it's just 4. So then we know that this would end up resulting in 5 over 4. And then this one, we can say that equals 3 minus 2, -3 minus -3 squared. So it's all decent, reasonably easy stuff. This will give us 3 plus 6, then minus, so -3 squared is 9, so minus 9, and then that ends up giving us modulus 0. And if we were to evaluate this, 0 squared is 0, and the square root of 0 just equals 0. If you can recall to earlier in the video, we discussed about a format similar to this, in which you use when you have more than one point for a function. So what we're going to do is we're looking at this first example here where y equals mod x minus 2. And so what we're going to do is we're going to use this format on this first question here. And so we can now evaluate this to become x minus 2 equals, and we do our brackets, x minus 2 if x minus 2 is more than and equal to 0, and then for this one we'll have to do negative, and I'll put it in brackets, x minus 2 if x is less than 0. And so what I've done here, so for all the points where there's an a on this one here, I've inputted this value in the mod into this to create this. So then we can evaluate this further, and I'll say, just to make sure we're including all the information, x minus 2 equals x minus 2 if, and what we can do is we can move this 2 onto the other side here, and that'll give us if x is more than and equal to 2, and I reckon I can do a bit of 2 there, and then this will be negative x plus 2 if x, and I just realised I'll scratch it out, that's meant to be x minus 2 is less than 0, so then this one will be x is less than 2. And now I'll just bring this one down to here, just so we have a good amount of room, and so we can say we've got negative mod x, and this equals negative x, and then negative x in the brackets, if, and we don't include the negative here, so just if x is more than and equal to 0, and if x is less than 0 there, and then we can evaluate that to this here, brackets here, negative x, if x is more than and equal to 0, and then this one will just be normal x, if x is less than 0. Alright, so now we've got another two similar but a little bit different examples here. And so what I'll do is I'll evaluate the first one, so that'll obviously we'll show that as x mod x plus x equals, and then we'll do our bracket. And what we'll do for the top is obviously x will come out the mod, so we'll end up having x plus x, so we'll put both of them in, and then we'll say that if x is more than or equal to 0, better 0 like that. And now for the next one, the negative a that we've got up here will only actually end up applying in this circumstance to the x that's in the mod. So we'll have negative x plus x if x is less than 0. And then so we can say therefore mod x plus x equals our brackets again, and then we'll have 2x obviously if x is more than or equal to 0, and then obviously adding these two together they're going to cancel out, so we'll end up saying 0 if x is less than 0. Literally that simple. So I'll draw some lines here and then we'll jump onto the next one. And so this one will be a little bit more annoying to draw, but I reckon we can do it. So we've got mod x over x, which will equal, and this is part of the annoying part, but we'll put a big bracket here, make sure we can fit all of them in. And so the first part that we'll do is we'll have x over x, because obviously the mod comes out, and that's if x is more than 0. So I'm not doing more than and equal to, because if x were equal to, then we're going to get something different. And so what I'm going to do is I'm going to have x over 0 here, and this is a different one, and that's if x equals 0. And then we're going to have a third one, which is our other one, so negative x because of the mod, over x if x is less than 0. And then we'll evaluate that further, so we've got mod x over x again, which equals, and then we'll draw our large brackets, hopefully that fits it all. And so x over x here, those will cancel each other out, so it'll just become 1 if x is more than 0, and then x over 0 is undefined, so I'll just write u and d dot 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 undefined if x equals 0, and then negative x over x equals -1, and that's if x is less than 0. Okay, so now we've got a bit more of a challenging one, and simply due to the fact that we actually have two absolute functions here. So what we're going to do, and it's a similar process, it just involves a few more steps, is we're going to evaluate both of them separately. So I'll do the first one first. So we've got 2x plus 4, which equals, oh, that's a straight bracket, there we go, 2x plus 4. Instead of doing if, I'll just do a comma to try and fit things in better, where 2x plus 4 is more than or equal to 0, and then where negative 2x plus 4 is where that's less than 0, and then we can evaluate this further. We can put that, and then we get this, and so this stays the same. And then if we were to evaluate this section here, we'd move that 4 over and then divide it by that 2, and so that would give us -4 over 2, so where x is more than and equal to -2, and then so for this one we've got -2x minus 4 now, where, and then obviously the same thing, but where x is less than -2. Now I'll draw a line to divide it here, and then we've got 5 minus x, which equals 5 minus x, so that'd be 5 minus x, where that's more than or equal to 0, and then negative, that's right, 5 minus x, where that is less than 0. Therefore, what we'll actually have to do for this one is we'll swap it around. So instead of having 5 minus x, we'll have x minus 5, and I'll show you why. But we'll put this in, and that will give us x minus 5, because obviously we swapped it, minus x, do some commas, and then what we'll do here is, this is why we need to swap it around, is we had a negative x there, which doesn't work very well. So what we can do is we can now have x more than and equal to 5, because we switched it around, and then for this one, x is less than 0. Now what I'm going to do, and this will be a little bit interesting, is I'm actually going to draw a line here first, my jagged line, but I'm going to actually create number lines for both of these two final ones, so that one and that one. So we'll start off with drawing the values. So we've got 2x plus 4, and we've got x minus 5, and so now I'm just going to draw a line for the number line for both of them. Try and keep them going parallel with each other down here so we can compare the two in a second. And then what I'm going to do is I'm going to mark the points that have been provided to us. So on the first one, the dividing point is -2, so I can draw a little marker there and write -2. And then on the second one, obviously it's 5, which is what it's supposed to be there, so I'll rub that out. And we can do 5. It's a very skinny 5, isn't it? Like that. And then this one's 5, so draw that there. And then what we're going to do is we're going to write the values in. So for this section here, where it's below -2, and obviously that's for that, we're going to put in that number there. So obviously that's -2x minus 4. And then on the other side, it's obviously 2x plus 4, as we've got there. And then we'll do the same for the next one. So below 5 is 5 minus x. And then above 5 is x minus 5. And now what I'm going to do is I'm going to draw some dotted lines along there. Hopefully it doesn't get in the way too much. And what we can do is we can create a final 3-lined function for this. So we'll say that f of x now equals, well, this is going to have to be a big one here, like that. And what we're going to do is we're going to look at this first column here, where we've got both this and this, which belong to that column there. So then what I can do is write that in, and I'll write negative 2x minus 4. And then what we're going to do is, because you might see that up here we've got a minus there, so what we have to do is we've actually now got to minus the 5 minus x, and then we'll say that this is for x is less than negative 2, because that's what that point is. And then we can do the same for the center column. So we've got 5, well actually we'll start with the first one, 2x plus 4, and then we've got minus the 5 minus x, and then that's for the range between negative 2 more than and equal to x, which is less than 5. And then the next one, the final one, is with the 2x plus 4 again, and then minus x minus 5, like that. And then that's for x is more than 5. And then what we would do if we had more room is we could evaluate these and or all 3 of them until they're more simple, and so we get something more like, well, we'd have a little thing here, there it is, like that, and then we'd end up getting negative x minus 9, x is then we'd have 3x minus 1 for negative 2, x 5, and then we'd have the final one, which would be x plus 9 for x is more than 5, like that. These kind of ones may seem quite complicated, but once you start to do it more often, you start to notice the key processes you need to follow, and then they begin to get decently easy.